morning, everyone. Welcome you all to the 9th Annual Embedded Systems Conference.
So I'm Product Marketing and Business Development Manager for MOXA India. Today I'm here to talk about future-ready technologies of computing and networking solutions, what MOXA provides. And when we talk about future-ready, so what do we speak about over here is three parts. One is the longevity of the product, okay. The second part is the data which it can handle, and the third part is the toughness of the product. So coming to the longevity of the product, so when I say longevity, it means the product usually which we from MOXA deliver carries a 5-year warranty, a 10-year life cycle. In terms of the data handling, what we can do is we can go up to the transmission speeds of 10 gigabytes per second, and we can even have higher processing speeds with the latest processors. And finally, in terms of the warranty. So this is one critical part when we talk about the embedded computing technology or the networking technology. So when you talk about networking, you think of a product being mounted inside an AC room like this with a cabinet, air-cooled, very clean room. But for MOXA's products, this room is actually a very clean environment. So our products are designed to be mounted outside in the dairy circle signal maybe. So that's the level of toughness and the temperature what our products can handle. So I'll run through the presentation. First, initially, we'll talk about three parts of the presentation. That's the day's agenda. First part is the MOXA's corporate presentation. Then I'll run through the embedded computing technology what we have. And finally about the networking infrastructure for IoT, IoT and IoE era. So to start with MOXA, we are a 25-plus-year-old company. We are reaching our 30 years next year. We have 35 million plus devices connected worldwide, and we are number one in terms of the serial connectivity, that is serial to Ethernet connectivity, and we are number 3 in terms of the industrial Ethernet infrastructure. And we have already been awarded as a best employer in Taiwan for the year 2013, and this year also, a couple of months back, we have again been awarded as best employer in Taiwan. Our vision is to be a trusted partner in the world of industrial automation, okay, and we promise to deliver sincere service and reliable networks. About our presence, we have 2 headquarters globally, one based out of US, California. The other one is the R&D headquarters based in Taiwan. California is mainly our commercial headquarters, and we have around 1,000 plus employees worldwide, and 35% of our manpower is dedicated for R&D. So most of the products or most of the solutions what MOXA has are customized to customer needs. So that's why we have a very huge manpower dedicated only for R&D purpose. Now, a small glimpse on the IIoT, what is happening in the world. So, by 2015, there were already 25 billion plus devices connected on the internet. That's in the industrial internet environment. And by 2020, it's going to double. It's going to be 50 million by the end of 2020. And overall, the impact what we see is to have a $82 trillion market in IIoT space by the year 2025. And just recently today, we got an update that one of the largest automation provider, products or the solution provider, expects to contribute $7 trillion US by the end of 2020 itself. So that's what is happening in the IIoT space. Now, when we talk about IIoT, what exactly are we talking about and where does MOXA stand? So when we talk about the IIoT era, so we have the basic devices like IP cameras or some meters, push buttons and many other sensors, actuators, etc., which are on the basic device level. And on the application layer, you can find the cloud infrastructure, the data processing and analytics, and the user application, everything. So what we do is we bridge the gap between the device layer and the application layer. So how do we do it? Is by having MOXA's devices. And do remember that whatever devices or whatever product range we are talking about come with all the predetermined things of our toughness, what we can provide, the reliability and the warranty. So we do have the edge connectivity devices like IP surveillance camera, some remote IOs in our range, and this is the number 1 product what we have, which we are globally number 1 player, that is the serial connectivity infrastructure. Then we have industrial routers, Ethernet switches, this is the networking infrastructure. We also have a Wi-Fi access point, again on the industrial grade. And finally, the gateway computers. So to do this, we also have device management, network management softwares, the remote I/O management softwares, and all these are targeted specifically for industrial verticals like smart rail, smart grid, your smart factories, transportation, and even marine kind of applications. So all heavy duty industry applications is what we target using these MOXA products. And we also, when we talk about the heavy industries, we are also certified for many of these industries. Like IRIS is a rail certification, we have ATEX certifications, and some other certifications which are related for those specific industries. And this is one thing which MOXA can exclusively do, is when you have an application, when you have a project where it goes for a very critical, mission critical application. So we can also certify the products what we sell specific for those applications also, and that's how our technology is growing inside MOXA. Now, in terms of the technology again, so what we're speaking about is we have invented various different technologies, like to say turbo chain, turbo roaming, click and go, and Dynastream, etc. I'll just give you a small example that about turbo roaming. Now, you might have all traveled in Bangalore Metro or Delhi Metro or Mumbai Metro or something like that. Normally what happens is that there should, in a metro rail especially, there should always be a communication between ground and to the train. Okay, so I'll show you an application example also how it happens. So the communication which happens is typically a Wi-Fi communication, and at every 10 kilometers you'll have a Wi-Fi access point mounted on the track side, and from the train you'll also have a Wi-Fi client which connects all the data of the train on the run to those Wi-Fi access points. So but what typically happens is when you cross from one access point to the other access point, there's a small gap, okay, or technically you'll have to change from one access point to the other access point. So the switching time between one access point to the other access point happens within 20 milliseconds, and that's the technology of turbo roaming what MOXA has come up with specifically for rail application. Now coming to the targeted verticals which we spoke about, so what we focus is on rail, power, oil and gas, smart factories, intelligent transport system, and marine, with all the necessary certifications for those application areas. So some of our great testimonials what we have, one is from the International Space Station, yes, because our products range from -40 to +75 degrees operating temperature. So we have our products installed in the International Space Station also, and we have the largest roller coaster what we have, what's there in US also has MOXA connectivity devices, and most of the metro trains or the passenger trains which run in Europe and US, and also the metro trains in India run on the MOXA's networking infrastructure. And some of our trusted partners whom we work with for all these projects, like for an example, we work with Alstom and Bombardier for the rail projects, we work with Schneider, Emerson and ABB for the power sectors, similarly GE, we have got many other partners whom we work with in the space of IIoT. And we also have some global recognitions in terms of the product awards what we have received for the products what we have developed. Industry awards in specific, we have a couple of for surveillance, for transport, for other kind of power infrastructure. So we have got those awards also. And as a company, we have always been awarded, right now it's the second time, as the best employee in Taiwan. Okay, so our main mission is to provide critical connectivity infrastructure, the networking infrastructure for IIoT applications. And we promise to have reliable networks and sincere service. So this is about MOXA's corporate part of it. Now we'll go in detail on the product range what we have, mainly for the computing technology, and then we'll go through the networking infrastructure what we have. So to start with the computing technology, MOXA has got 4 main platforms. One is the compact computers that are either RISC computers or x86 computers. We have got the 19-inch computers also. These are the rack mount computers what we have. Then we have some specific display panel computers, and we do have some software utility which is utilized to manage all these computers in specific. So what is a core strength in these three in the computing area is to have a easy programming capability, robust design, and versatile communication. So these are the 3 key pillars for MOXA's computing technology. starting with the compact computers, that's starting, the basic range comes with UC8100, which is a RISC-based computer. It works on Linux platform, and we do have our own integration software called as Things Pro. I'd like to highlight this particular part a bit, that is Things Pro. So this is a tool which we have developed on which any of the field devices, like which we spoke about, meters or sensors or push buttons, can be directly connected to this particular computer on serial network, either RS-232, 485 or 422, or even on Ethernet. So it has got 2 LAN ports to do that. And with the Things Pro tool, you can just copy paste the URL of your cloud, and all the data of your field devices is directly uploaded to the cloud. So it's the most simplified format of getting any kind of field data to the cloud or to any application layer or to the data layer. So this is the simplest form of computing technology what you can see, and more or less it is all 4G enabled. So it all runs on the cellular technology, which makes the communication much more better, easier, and you can use it in the most remotest locations also. Some of our remotest locations include the border areas of India, wherein the surveillance data or sometimes other field information is being transmitted to the central server using the UC8100 product, which runs on 4G or maybe 2G or GPRS, whichever is the network available at that area. And on the same platform, we have got various different computers. So this is a very basic one with the IP30 protection model. We have an IP67 model also. This is for the very tough environments wherein it has to be mounted outdoor rather than in a specific panel. We have a box type computer also in this with multiple serial interface options where you have too many devices to be connected, and all these, and finally the x86 version, that's with the Windows OS embedded. So all these computers are again 4G enabled. You can also have the access on Wi-Fi in this particular range of V2201. Also with the serial interfaces, the network interfaces of LAN, along with the HDMI interface if you want to connect a display and monitor or program the device. So all the things are embedded and built into the device itself. So there's nothing extra in terms of a computing platform which you need to buy or which you need to source. Next range of this particular compact platform comes with the UC8100 series again. So here we have the wide temperature range computers ranging from -40 to +70 degrees with LTE, and all the products which we have in MOXA are fanless technologies. Okay, so the main advantage is you will not have any dust accumulation inside the devices which will hamper or which will have problems in operating the product. So that part is avoided by using the fanless technology which MOXA provides. So some of the best example use cases which we'll talk about it. First one is the solar farm, wherein you have got various solar panels and you have got the inverters which provide or generate a lot of data. So you need to collect kWh. Sometimes you have the solar, this one for pumping stations, etc. So you need to collect a lot of data which is available either on serial or on Ethernet network, and it has to be transmitted to a central location wherein you will do all the data monitoring, what's the flow rate, so what's the kilowatt which it has generated per day. So all this thing can be accumulated on the UC8100 device and transmitted via cellular network to the central server. So this can be used in various, again, different types of applications. So the key thing over here is it's a ready-made solution. You need not spend a lot of time on programming. Everything is ready-made and you just need to connect it and configure it, that's all. So the developers or the programming engineer's life becomes much more easier. So the next part of this technology also is implemented in the highway traffic, where in India it would be very difficult because considering the bandwidth of network what we get over here to transmit the IP surveillance data, but we have done it in China and in Europe, wherein we transmit all the surveillance data wirelessly to the central controller. So it helps avoid a lot of cabling because you need kilometers together of like hundreds kilometers of together of optical fiber cabling to transmit all this high density data to the central server, and that can be avoided and easily done using the MOXA UC8100 series computers. Similar to that, we have another use case or the application story of monitoring the dam water level using the IP surveillance cameras of MOXA, some IO controls, etc. connected to the UC8100, which again transmits the data on cellular or on Ethernet technology directly to the central computer when all the monitoring happens. And this is one recent story of India. That's with the Indian Navy. Sorry, I cannot give too much details about it because we have a non-disclosure thing. But just to give you an example, on a warship, there are various different areas of the warship wherein a lot of data again is being generated and it has to be provided to the central area of the warship itself. So what we have provided is the field devices connected by either via Modbus or via Ethernet to the UC800 computer, which is again ruggedized because of the warship conditions, with all required certifications of ATEX, the marine certifications, and on Wi-Fi we'll be able to provide all the data to the central control room of that particular warship. So this is one of the latest Indian success stories what we have. Now coming to the next part of the presentation, that's the 19-inch computers and the display computer part. So when it comes to 19-inch computers or the display computers, these are something which are specifically targeted for some verticals like marine, oil and gas, power and rail. So these are not more generic like what we saw previously for the compact computers. These are specific to certain verticals, and these are open computers wherein you have got either the computers on Linux platform or on the Windows platform. Let's start with the power part. Now in power we have got various different ranges of computers depending on the CPU speed what you need, depending on the storage capability what is needed, and we differentiate it in two different parts. One is the non-IEC 61850 compliant, one is the IEC 61850 compliant. Now some of you might remember a couple of years back we had a problem in northern part of India wherein the power grid failed and there was a havoc in Delhi and many other northern cities. So post that what has happened is India plans to implement most of the power grids on IEC 61850 technology. The key differentiating part of this particular technology is that when a data is transmitted on the ring, usually it is transmitted on one side of the ring, which is either the shortest or the best suitable path. In the IEC 61850 technology with compliance like PRP, HSR and KEMA certifications, what happens is the data is transmitted on both the sides of the ring simultaneously, and the data reaches to the end node. The first data which comes or the first packet which comes is considered and the second packet is discarded. So this ensures a very fail-safe technology of data transmission, and the compliance required to do that is called as IEC 61850, and our computers are already certified to do this particular job. Now some again use cases of our power computers is for the unmanned power substations. This was done, this particular job is again an Indian project wherein you have got various field devices in the substation like IEDs, your transformers, your current transformers, etc. All those things connected on the Ethernet backbone of MOXA, that's the switches or the serial to Ethernet converters, etc. Coming to the central computer, that's the 19-inch standard computer wherein the power SCADA is loaded and all the monitoring and connectivity happens on this layer of the computing 19-inch computing solutions what we get. Similar type, another power substation example. So there are various three layers. One is called the basic starting layer, then you have got the bay layer, and then you have got the substation layer. So again here, everything in this particular job is PRP HSR compliant, that's IEC 61850, wherein everything is on a ring and the data transmission happens on both sides of the ring which I mentioned. So to make sure that there is a fail-safe operation of this particular substation. So typically why this kind of technology is required is, for an example, if you want a circuit breaker to break at some particular time or due to some particular error, and you transmit the data on the ring and the ring fails on one side. So if the breaking doesn't happen, it might cause a big disaster on the power network or on your substation network. So that is where you need the PRP HSR technology or the IEC 61850 technology to make sure that there is a fail-safe communication and the data is always sent to the required device. Next part is the railway computing technology, wherein we are compliant to a standard called as EN 50155 and also another standard called as IRIS. Now when we talk about a railway computer, typically it's not a computer which is mounted on the station or which is used for your ticketing applications. It's a computer which is on board the train to gather all the data required generated in the train. Suppose your HVAC data, the data of your engines, the data generated by other transmission and electrical systems of your train. So all this data has to be computed on board the train itself. Now the differentiating point of a rail onboard computer is that you need to withstand all the vibrations, the shocks, the environmental status inside a train. Typically in a bogie it is much more easier, but when you do it on the engine side, it becomes much more difficult. So that is why we have some specific computers designed for railway applications itself. Now, how different is it? In terms of its construction, it's different. In terms of the temperature which it can operate, in terms of the vibrations which it can handle, and also in terms of the connectors what we use. So typically these connectors are the LAN connectors which we use on a normal laptop. So instead of having the normal RJ45 jacks, we'll have specific M12 connectors which will make sure that in any kind of vibrations the connectors don't come out. So that's the differentiating technology what we have in terms of the railway computer. And our global install base of railway computer is something like this, more or less everywhere in the globe. In India, we are still starting because the Ethernet backbone in the railway network is still coming up. So RDSO is talking about it. Probably in another 2 to 3 years, we might even have India on the map for our railway computing technology also. One case of India wherein we had supplied V2406A series of computer for the ticketing applications. Now what exactly happened in this particular project is that Indian Railways in couple of stations they were having too much dust and that's what happens in a railway station until before the Swachh Bharat campaign came in and we started cleaning everything. So there's a lot of dust and every 6 months or every 3 months a computer used to fail, the ticketing computer, and they had to replace the computer. So that was the challenge which they were facing. And normally on an average computer would cost somewhere around 20 or 25,000, but this would cost maybe more than a lakh or so. So the discussion point with the customer was that why do I need to put a lakh rupees whereas I can keep on replacing the computers. So we gave them one as a sample piece just to try out how they feel or how they utilize it. So post 1 year there was no failure, and even that also it's been almost 4 years now wherein there's no failure of this computer. So that's the kind of reliability what our products provide in terms of the toughness and the construction, which makes sure that there's no fail. It is fail safe. So that's the differentiating point of MOXA of the customer when they use MOXA, and they prefer to after that they started implementing all MOXA's embedded computers instead of having the standard desktop PCs. Another application is on board in Taiwan Railways, wherein the embedded computer is mounted on the train directly, which monitors the surveillance systems, which monitors the HVAC data, the engine data, everything, and transmits it via cellular network to the central computer. One of the recent success stories also what we have is in Europe, wherein we have an embedded computer on board some of the Euro rails, and that computer can have up to 8 SIM cards built into it. So why 8 SIM cards is that in Europe the trains travel from country to country and the service provider changes, or will have different bandwidths, or the bandwidth might not be enough to transmit the data. So we have a computer with an option to connect up to 8 SIM cards, and this was specifically made for Europe Rail, wherein they were using the computer with 8 SIM cards and continuously transmitting the train information data along with the GPS data of the train, which is mandatory anyways, to the central location, and it was happening seamlessly. Next part is the oil and gas computers and the marine computers. So these are typically either the standard rack mount computer range what we have, either in box type or the compact one or the din rail mount type, with all the certifications required for marine and oil and gas applications, with various different processing speed and the types of inputs what you can give to the device, either serial, Ethernet, or any specific communication like CAN or Profibus to interface with the field devices, the existing field devices. And we do have a range of display computers which are used in marine applications, specifically marine and oil and gas applications. We'll see a couple of success story examples which will help you understand more. So this is one of the offshore drilling project what we have done, wherein a marine computer is installed on the oil rig itself, and the environment in which it operates is all oily, very it's not dusty, it's more of oil and it's not at all clean. So, and the operator also uses gloves to operate his equipments, everything, but the challenge was to have a computer which can operate by wearing a gloves also. So, and also sustain all the natural elements like oil and other things, and still be able to operate in that particular environment. So, this particular series of computer was able to operate in such environment, and we can even operate this particular computer using by wearing a gloves also. Similar kind of applications, this was for more onshore application, wherein the panel computer or the display computer is mounted in the various areas of the drilling rig or the oil plant, and the same kind of requirement of using the panel computer wearing a gloves with higher processing capability with required certification. And specifically when it comes to oil and gas, you need a certification called as ELEX, which is more of explosion proof certification. If there is an explosion, the device should not get damaged or the device itself should not explode. So that kind of certification is what we had to provide in both the oil and gas applications what we have seen now. Coming to the final part of the presentation, that's on the MOXA network infrastructure for the IoT and IIoT world. Now, to give an overall view, I'll not go in detail in every product. So, to give you an overall view, the part of the products which are not part of MOXA are the PLC, meters and sensors, but anything above that. For an example, serial to Ethernet converter. This is something which I spoke about in my first slide, that we are number one in terms of the serial to Ethernet network connectivity. So, this is the product which converts any kind of serial network to the Ethernet platform. Then we have the media converters, which are nothing but Ethernet to fiber, copper to fiber converters and fiber to copper converters. Similar to that, we have the field bus converters, wherein we convert different protocols like Profibus, Profinet, Modbus TCP/IP, CAN Open, and convert them to Ethernet protocol. And again, using the device extenders, we can transmit it up to the switch. And also, we have got specific PoE switches for the IP surveillance camera system, and the remote IOs again enabled with Ethernet. So all this connected to the switch infrastructure what we have, and it connects to the next layer, that is the rack mount switches, which you can see over here. So the communication usually happens in 1 gigabytes per second communication speed, and above that we have the core industrial switches range, that in which we have the 10 gigabytes per second communication speed. So this is the networking infrastructure what we have for the generic applications, but similar to what we talked about the power market, the oil and gas market and the railway market. So we have switches which are dedicated to handle the technology of IEC 61850, EN 50155 in terms of railways. So we have specific switching infrastructure even for the power and railway applications. Also we have got the wireless access points which are dedicated for rail applications or even for power applications and any kind of hazardous environment application. So all this infrastructure can be managed by our industrial network management, so software, which will be utilized to have a supervisory control over all the devices what MOXA provides. So coming to the same part, so where all we have our infrastructure being installed, which we spoke about in the beginning about the turbo roaming technology. So on board the train you will have the Wi-Fi access points, and on the way side of the train, that's on the track side of the train also, you will have similar Wi-Fi access points. And the data transmission happens seamlessly, so that the train movement or everything, all the data of the train can be tracked without any interruption. And we can also have a similar kind of Wi-Fi access points, which is the latest thing what Indian Railways is coming up to provide Wi-Fi access inside the railway, inside the train itself. So this is some technology which we are already working on with Indian Railways. Another example of smart grid, which we already spoke about in the previous slides. So we have a power computer. So we also have the network infrastructure for the power applications with PRPHSR technology, IC 61850, and even KEMA certified devices, specifically meant for the power grids or the power applications. And for the oil field also, we have similar devices. We even have some specific IP cameras which are again explosion proof, that is ETEC certified, connected on to the network infrastructure provided by MOXA, which is also ETEC certified, so to operate in oil and applications. And also for smart factories, wherein you have got various high temperature situations like in a foundry or in any kind of metal processing plant or in a mining plant. So we can provide the network infrastructure as well as the computing infrastructure for the smart factory applications also. ITS, this is the Intelligent Transport System, and this is wherein India is also gearing up to have IP surveillance on the highways or on the city infrastructure. So the infrastructure, the IP cameras, everything will be directly connected to the Ethernet switch backbone what MOXA provides. After that, it will go on the fiber technology, a fiber ring, which again will have the fiber connectivity along with a switch and the central computer, central control station, where it will also have a switch of MOXA connected on the fiber ring technology. So we can provide either the computing technology for the central server room or even the networking technology for the actual on-field applications. And the final part is the marine display computers, which we have discussed earlier. So we have specific computers dedicated for marine onboard ship applications and also the networking infrastructure backbone which runs all those computers. So this is some specific technology which we can give in marine applications by MOXA. So that's about my presentation.